Welcome to the special edition of Databricks Release Notes Decoded. Today we have a special guest, our CEO, Mate, to give you first-hand insight into the Data and AI Summit. We've invited him so we can deep dive into the features that aren't available to the public yet. Welcome.
Thank you. It's great to be here.
You said that Databricks is not the data and AI platform anymore, it's the enterprise platform. What do you think the biggest moves that signal this change in Databricks are?
Well, I think the initial signals were the what I call the last mile features in the platform, like Lakebase last year and apps, and also Genie. But now, for instance, the fact that Genie 1 also queries data or uses data outside of the platform, which is the first, but not the only feature that reaches out of the platform, like outside of the platform. So Genie 1 is one platform feature, and the other one is AI Gateway, which also reaches out from the platform itself because it is a governance layer across different vendors such as Anthropic or OpenAI, MCPs, and others. The platform is now Databricks, but it's like an overarching governance layer across other things, other platforms even, like Anthropic. So that's number one. Number two, if you look at Lakewatch or if you look at the CDP that Databricks announced, basically it's the application layer. And that's what's happening across the industry. Everyone wants to be the interface to the business users. Anthropic wants to be the business user, and Databricks wants to be the interface. So the apps is the biggest feature there, but also Genie 1, the mobile app. So in the past, we always used a mobile app, and Databricks was the background, basically, the backend. And that's maybe not the case anymore. So we ask Genie from our phone and also in Slack and Teams.
So these are the biggest technical changes. What do you think the biggest changes are in terms of human or organizational standpoints in Databricks?
Well, I think the technology is really ahead of what most organizations can implement today, at least on the agentic side. It's very interesting to see where most of the organizations are and where they could be from a technical point of view. And the technical maturity of the platform is way ahead of that. So Lakebase real-time or Omnigent or all these features are for agents where you run a lot of agents or an AI gateway. Most organizations are still hoarding the data into the central place. And that's where their problems are most of the time, and how to manage that in the organization. But everyone feels that they are behind because there are new companies starting with an AI native approach. So they will use Databricks and all these features from day one. So they will put all the data in the Lakehouse, so they don't have the migration legacy. They will create a business process with agents in mind, so they don't need to migrate their operations on top of their data. So I think that's a big challenge for a lot of companies. And some of the features are helping existing companies, like the ontology, which is a ground-up version of the semantic layer, and that helps organizations make use of agents. But yeah, it's a big shift for all organizations, and I think if the organization is slow, generally, it's going to be very difficult because the technology runs really fast.
Yeah.
So the competitors who can run faster will now have the platform to build new customer experiences, to run more efficient operations.
Let's unpack that a little bit. Let's talk about the data in the data platform.
Yeah.
Let's talk a little bit about the biggest announcement here, which seems to be LTAP. First of all, just to unpack this a little bit, LTAP is Lake Transactional Analytical Platform. It is also an intentional play on HTAP, which is a database design principle. Could you elaborate a little bit about this feature and this new sort of Databricks feature?
Yeah, so it's one of my favorite features. I have a different set of favorite features than most people. partially from my background, but also because I work with customers. And when I started more than 2 decades ago with data, there was a simple rule that no one thought that it will ever lose its validity, which is you have the OLAP word and the OLTP word. So OLTP is the database you use for operational purposes. So when you have a user who changes the username or the photo, then you update in a database, the Postgre word. And you have the analytical word, where I spend most of my time, where you query the data. So you want to understand what cohort of users I have, how they perform, what features they use in the platform, and so on and so forth. So when you want to analyze the data that's in the operational database, then what we've done, we copied the data to the Lakehouse or to a data warehouse before that. And how we do that is usually through CDC, so change data capture, or through like LTAP was an attempt to somehow unify these two parts. Because this connection where you replicate the data, it carries a lot of work, risk, because there might be some issues. And then there's a latency to the freshness of the data. So it's a common problem with dashboards, that you just don't see reality as it happens because there's a latency. And then there are the 2 ways that we as an industry try to solve it is either through trying somehow to automate the CDC, or to create one engine that can do both. And that's one example is SAP HANA that tries to do that. The problem, it's very, very difficult to optimize for both operational and to analytical. So if you go to the technical details, why it's difficult, because when you want an operational database, you look up per row, because you want to update one specific row. So when the user updates it, we can find the row. Versus in an analytical, I'm interested in the average page on time spent on a page for a specific customer group. Then I want to run statistical analysis on multiple rows. So in the operational world, we store row by row, and in the analytical world, we store by column. So what LTAP does is it unifies on the storage layer. So it's still 2 engines. The engines optimize for their respective way to access the data. Operational is still row level and or row focused or row oriented, and the analytical is still column. But what happens is with the Neon technology, which is lake-based, in Neon still wrote the data to the object store in a row-oriented way, but Databricks since replaced that, and now it writes to the Delta or Iceberg we all know and love. So basically now the engines are still separate, and they will stay separate, but now on the storage layer they write to the same format, to the same way, which is a column-oriented. And so now there is no CDC. There is no copying because it's the same storage. It's the same copy of the data, though with 2 engines.
Then how is this exactly better than the existing solutions? Because even in Databricks, which not counting anything else, we had many solutions attempting to unify these. We had, without exhaustive list, sync tables, online tables, and Lakehouse sync as well. Lakehouse Lake-based CDF, and Delta also has a CDF functionality. Yeah. So how do you think those features will live in the future?
So some of the features like on ETL, they will stay because ETL is still there. Because we still want to modify the data. Yeah. And we also have a lot of other sources that are not in operational databases. However, like if you think about synced tables, those are like solutions to ease the pain of moving or keeping 2 copies of the data in sync, basically in the same state. So that disappears. So if you have a database either as an operational database as a source system, or you serve, let's say, a dashboard, now you don't need to maintain 2 copies of the data. A good example is, so if you have a user database and you use Lake-based for that, now you can analyze that table. You can still do the normal, like, move that to a gold layer and serve it for dashboards in a different aggregation level. But you can also now just either analyze the data in the operational database or use that as, for instance, and this is, I think, a very interesting question, is that bronze layer or silver layer? But basically, it's part of that same estate now because there is no copy. So I think that some of the features are solved with that, like the sync tables, and some will stay because they help an overall ETL process.
Yeah. I'm very glad that the many different names are going away, but more on that later. What do you think this will mean for users of Databricks, admins of databases? Do you think more classical database-oriented people are going to come to Databricks because of this? Why do you think the managedness of this is going to be?
Yeah, I don't think that this in itself is the feature that will suddenly convert people who are not using Databricks per se. I think generally the unified end-to-end data platform is still the biggest value proposition, especially now that where it starts is still roughly ingesting table. Maybe there is an interesting part here that the Postgre and the Oracle that was an operational database in many cases now can be part of the Lakehouse, especially that Lakebase has managed disaster recovery. So that was a big issue because if it's a critical application, then you need disaster recovery on the data. Otherwise, you lose access to a critical app or a critical data that you need to run some process. So that moves the let's say left side of the platform towards our operational databases, and then also the apps push the other side. So I think this movement will bring people to Databricks, that I can use one platform and I can store the operational data, analyze the data, build analytics on top of that, dashboards, I can build automations, I can run my agents on top of that, and I don't need another layer to govern all of that and solve the different securable models and the different identities and so on and so forth. So I think generally is still the unified platform is the keyword, but what we mean under unifying is now a much larger surface. And I think that will bring a lot of companies because we can clearly see where the AI and the agent world is moving. So I don't think you can be a modern organization without the data platform.
Yeah, I see. So let's talk about another topic connected to this Lakehouse RT or Lakehouse Real Time, also powered by the Reyden engine, that's Reynolds' dream engine. So you were on the summit, you probably talked to a lot of people about this. Can you tell me, internally, I think it's a pretty funny name and sort of giving him the whole idea. Was this truly his long-time plan to have something like this? And what exactly is Lakehouse RT?
Yeah. So on the name, I think I think the official name is Lakebase or Lakehouse Real Time or RT, but I think we should call it Reyden. And so what was before? I think that's the starting point. We should talk a little bit. So when we have the data in the Lakehouse, often how we want to use that data requires very low latency. I worked in many projects in digital advertisement, where you have to serve like a banner in less than 100 milliseconds. So in that case, even though we have the analytics, for instance, which ad to serve to a specific user, you can't use the Lakehouse without a layer in front of the ad serving, because querying through a SQL server was just too long. The other problem with the latency is agents. So agents query a lot the data, and agents are only as fast as the queries can finish. So the real-time engine is a third engine. So because we talked about the lake base, we talked about the, let's call it classic Lakehouse. And RT is a third engine. So it's a SQL warehouse, comes in multiple sizes. And inside it uses the Reyden engine. And in the past, as far as I know, Databricks tried to do this. So this is not the first time, but rewriting an analytical engine is just a huge job, even considering Databricks is multi-thousand engineering org. But with coding agents, the work, at least in calendar time or engineering effort, was reduced. So that's, I think, one development in the last few years. The second thing is, the problem with real time is that it's very, very difficult to create a real-time engine that can work across different workloads. And by workloads, we mean what type of SQL query do you run? Is it a lot of aggregations, a lot of joins, or is it just purely selects? Or what type of, or is it like really wide tables, or is it really long tables? So there's all these different aspects of a query, and then you look at an organization, or let's just look at the data. What is the dominant query type out of all these different dimensions? And to write one engine that can work really well across all these is very, very difficult, because you change something to make something better, and something will break, at least on the performance level. So this is what I think in maybe one of the presentations, I'm not sure if it was in the keynote, but they compared this to like a whack-a-mole, where you try to do something, and then 3 other things pop up that now you need to fix. So the second thing that that Databricks can do now is they have the patterns, so not the queries and data, of course, but the patterns, the dimensions that I described, for all of their customers for the last decade. So that's a super valuable data set when you think about the whack-a-mole problem. And they train machine learning models on top of it. And they developed the Reyden engine with this performance gate.
Okay.
And basically, they can test it across all these different patterns, and they don't add a single line of code if it reduces performance by even a millisecond.
Okay.
So what they can do now is they can, and it's very interesting that it's a performance problem, it's an engineering problem, but the solution is some kind of quality assurance, or some kind of testing, which is a very interesting aspect of it. And so it's not like a magic algorithm that they found, but more like an approach that no one really used for engine development. And so this is if you go back to the previous point, now we have a single storage, Delta and Iceberg, open, and on top of that you have the operational database, Lakebase. You have the traditional analytical engine, which is Lakehouse or normal SQL warehouse in more technical terms, and you have a real time. And that, if you have now a ClickHouse or a Vertica serving real time, you can basically, the promise is you can replace that with RT and Reyden. And so again, you don't need that ETL that you did before to get the data from the Lakehouse to Vertica or ClickHouse or Pinot or others. We still have to see how it performs. So the numbers are pretty good, but the numbers are benchmark numbers. And this is where the most interesting thing will be, what is the real-time performance when it comes to RT?
Yeah, but let's face it, I mean, they also changed from JVM to Rust. That was also like a
Rust.
big... Yeah, it is Rust, and the JVM has been around for so long, I think, you know. It was time to go, time to let go.
Yeah, but even there were cracks on the because Photon was pretty heavily done on C++.
Yeah, it was C++. I think Photon was sort of the precursor to what Reyden could be, and then just but still using the JVM. So I think you went into this pretty well, but just to recap, so where should customers see the most improvement when we are talking about not just RT, but LTAP and RT together, for example? Where do you see the biggest advantages?
So I would separate the two, right? So I think Lakehouse, so the agents narrative or the angle that agents will use, that most organizations are not struggling with too many agents who lack real-time access to the data. But the real-time piece is really the serving layer for most companies, as like at least today. So if you are maintaining, again, and I don't want to hurt the ClickHouse or Vertica business, but if you have a ClickHouse and a Vertica or a Pinot, then you can maybe consider consolidating and saving cost and engineering hours and probably problems and errors and bug fixes because you make a mistake in the syncing and or in the code that you use to sync. And so that's the biggest one, right? The less thing we need to maintain, the better. And the whole point of the Lakehouse is we have a single source of truth. And the more we can collapse into that single source of truth, the easier our job as data engineers and as a team who are responsible for the data is. The second thing is the LTAP. LTAP will come, so it will be rolled out over time. Yeah. But if you have a database that you replicate to the Lakehouse, consider bringing that to Lakebase. And now you don't have to. I mean, once we have LTAP in GA, but then you don't have.
Yeah.
And there's a lot of advantage to Lakebase on top of LTAP. For instance, you can branch, which is something that if you're a software developer, like imagine your work without branching, without Git. I mean, Git has version controlling, but just even without branching. And but that's the reality of operational databases. So the way we branch or the way we task something on an operational database is we copy it. There are ways, right? Postgre actually has a pretty rich ecosystem, but still it's not native. So there's a lot of the other interesting topic here is operational databases. At least many people thought that it's like a solved problem, so you don't need to. It's very difficult to innovate. Like Postgre, I think the biggest change in the database industry for me was that after MySQL, we mostly use Postgre. Probably if you are very deep into the Postgre world, you would not agree with the statement that there was not a lot of development. But like conceptually, I don't remember large changes of what we expect from an operational database. But that's also changing with Lakebase. So consider bringing your operational data to Lakebase.
Yeah. I mean, definitely when we talk about data lakes, data warehouses, and then data lakehouse, it is a much bigger shift than we had a database 30 years ago. We still want to have a database now, right? So that's definitely still true. Moving on to sort of the bigger picture a little bit, leaving the data platform behind. As we discussed, Databricks is now the enterprise platform. It is also entering sort of new segments. One of them is customer lake. Could you elaborate on that a little bit? You have some experience in there. So could you tell me what that is and why do you think that's a huge sort of step for Databricks?
So I would start every aspect of a business where you have customers, a lot of customer experience depend on the quality of the data you have about the customer. So I have most of my experience in customer experience in retail banking. So if I'm a customer of a bank, what type of email do I get? And when do I get the email? Do I get an email or do I get a push notification? Depending on which one I like. For instance, I don't like push notifications. So if the same message gets me in a push notification or in an email, I will probably have a negative emotion towards the push notification and maybe a positive, depending on the message, but might be a positive in an email. So that's also a knowledge about me that the bank should have. What is the channel that I prefer? But also the language is another one. I got many offers for products that I have absolutely no interest buying, for instance. And if you look at my spending habits, the type of products that I use, then it should be pretty obvious that a product is not really something I have any likelihood to take. So, and the customer platform is in many features, but solve that central problem. But what makes a data good quality from a customer experience perspective? One is how much we know about the customer. And again, just coming back to the retail bank example, there is the core data, my age or birth date or name, email, but also what type of products do I have? Did I contact the customer service? Or what did I say in the customer service? There are regulatory limits to what you can use, by the way. So banking is
thankfully
it's a good example where you have to also consider what's possible. But technically, the more data you know, like which branch do I visit? Do I visit branch or do I use the mobile application most of the time? What do I do in the mobile application? Am I a football fan? Because if you're a football fan, a lot of companies have football campaigns or World Cup related campaigns. So the CDP was already a very interesting ecosystem where the more data you have, the better the features and experiences you could build. And now with agents and AI, we got even new tooling to make even more custom experiences. And so if you look all of that, Databricks is kind of the perfect place to do that. But in the past, it was all either built by the customer themselves or third parties. And I think what Databricks realized is that the best place for customer data is on the lake anyway. So why not put the application layer? And this is where apps comes in, because Databricks now has a natural application layer, or at least a platform to host it. And the good thing is that in the apps, it was quite expensive to run applications that you only used once a week, once a month. But now we have micro apps, which is a serverless solution that on Databricks you can use, and it scales down to 0. So your costs will collapse if you have those applications. So now the customer lake is this, what we call CDP, customer data platform. But because it's Databricks, and Databricks knows a lot about how to build agents, it's agent native. So they do a lot of things instead of writing processes or something, they use agents. So one of the issues is in these different systems, I might have a different identity, a different account for the mobile app or for the payment. And so there is an identity resolution agent that matches my different identities. And there is a campaign agent that can create campaigns. So it's maybe it's a bit of a rough parallel, but you can have a lot of marketers running the ideas on this data. So instead of just the humans actively thinking what would be a better way, you can proactively generate ideas and test them on the data if you have better ideas. There's still the control there, and this is, I think, what Databricks called it, the infinity campaigns. And this is certainly not a banking example, but you could, if you see that I buy an airline ticket and I buy a sunglass, then you can give me offers for travel insurance immediately, or start a campaign to buy maybe a swimming trunk or something. So there is a lot of things that you can imagine now happening with customization and personalizing all different experiences for the customers.
Yeah. So Databricks is entering this new space. Obviously, there are well-known and well-established players in this CDP space. What do you think the biggest advantages of Databricks is? From my point of view, from what I've seen, is it going to be the data platform aspect, the governance aspect, that they can control every bit of data? What do you think?
So one is that even before the customer lake, I think the best place for your customer data was the Lakehouse, because that's where you can connect a lot of different things. So if I can call my bank, and the bank and the customer service person has zero idea that I just had a complaint a couple of days ago, but maybe on a different channel, like I gave a feedback on the mobile app, I feel like I'm not heard. And this data siloed created sometimes really negative experiences for customers. So even before I think bringing the Lakehouse was a good idea, so the data platform aspect is one. But the second is, we clearly see some of the use cases where agents perform better or cheaper than existing solutions, or they open up new experiences. Again, maybe not in the retail bank, because it's a highly regulated industry, but in retail or in digital experiences like a mobile app, you can do much more with agents. Like personalization, for instance. How we in a betting app, what kind of bets do we surface and with what message?
Yeah.
I just heard it yesterday actually that if I'm an England fan, maybe don't push the Congo bets to me because I'm not gonna bet on that. But or what kind of news next to the betting do you surface? So I think the agentic approach is very future-proof because right now what we already see, it's quite likely that agents will have a very important part in hyper-personalization and customer experiences. And if you have agents, then you need the governance, the data, and the technical aspects of the data platform, like what we talked, that agents query the data a lot, so we have real time, and then they need databases on the go, which is the branching in Lakebase. So the technical aspect of the platform makes Databricks the best place for agents, and this will be an important aspect of a customer platform.
Yeah, thank you. We've mentioned agents a few times already. I think it can be also a very heavy drinking game if we drink every time we mention agents. Let's talk about Omnigent, which is a harness for all of these agents, switching over to sort of the coding side of using agents. It's an open source project, was announced before the keynote, but also Mate came out with a nice, snazzy pink shoes. I've seen that. I think that's amazing. Why do you think they open source Omnigent?
I think there is an answer based on just how Databricks worked in similar situations in the past. So if you look at Delta, if you look at MLflow, these are now one, if not the most popular open source project. So Databricks always creates new technology with an open aspect. And if they can open source, then they open source. Or even in the access part, for instance, Data and Iceberg, and they have an open approach. So I think generally it's in the DNA of the company. So I imagine that in most meetings they just have this natural tendency to ask, can we open source it?
Yeah.
But also I think they understand the power of open sourcing and the trust it builds with developers, but also I think technical decision makers like CTOs, because vendor lock-in always comes up, and Omnigent is a very good candidate to open source because it's targeting developers mostly. The more people contribute it, the better, because it's a meta harness. So their meta harness means there are harnesses below it. So the more people develop ways to connect to other harnesses, the more valuable the meta harness is, and the more people use Omnigent and give feedback, even people who are not using Databricks. So I use Omnigent without Databricks actually. I think the better the product will be for everyone. So I think that's the second aspect. The third aspect is with MLflow. I think you can use MLflow perfectly fine without Databricks, but in an enterprise environment, you still need a data platform. So I don't think Databricks loses a lot here, especially with, if you look at in how MLflow worked out, then Omnigent also has this enterprise aspect where you want to have the governance in one place. So you will connect it to a central place anyway, and the workspace in Databricks will come with the managed Omnigent server by default. So it's going to be a natural place for that server. I think that's the reason.
Have you used the Omnigent so far? Yeah. What do you think the most important or the most useful feature that Omnigent has
that depends. Actually, I talked to Brooke, who also in Databricks, who uses Omnigent quite a lot. Check the interview if you haven't. So, for instance, if you use multiple harnesses like Codex and Cloud Code, similar how she described in the interview, then the meta harness, just by the nature of being one place where you can control and use multiple harnesses, it's the biggest benefit, I think, in my view. But I only use Cloud Code. So I don't use Codex. So for instance, for me, the other benefits are larger. For me, the biggest benefit is actually pretty nuanced. It seems like a tiny thing, but you know when you have a session and you write the prompt and then the code gets back and you review the code and you take one part out of it, I copy it into the prompt and I say, hey, change this to that. And then I run it and then I do it again. But the reason why I do that is because I don't want to shove everything into one prompt, but I actually have multiple points I would like to point out to the agent and ask some kind of modification. Yeah. So in Omnigent, you can create comments because it supports collaboration, and you can do that with your colleagues. But I'm alone in this project, so I don't have colleagues working yet. We'll see. But I can just comment in the code that the coding agent created, and I can write the comment, change this, or I don't like this because I think it should be simpler by refactoring or whatever. And then I can send all of that in one go or one by one. So now my review is much faster because I don't need to copy paste and go and wait for the answer, but I can go through the review, do every marks, and then just send it. So that's the one that I like the most. And the second is policies, because you can create policies, and it's very interesting new. But most people don't realize is in policies in data is usually we define the policies on the data. So it's per row, per column. It's an access-based policy. But with agents, it's really an action-based policy. So what you want is make a definition or make a distinction between a dangerous action or a harmless action. Yeah. It doesn't matter if it's your production or dev environment. Obviously, production is more sensitive, but even in a staging environment or a dev environment, you don't want an agent to tear everything down. Yeah. So these policies are action-based, and that's where you can see the benefit of a meta harness. And then it also comes with a sandbox and others. But for me, the policies and the markup are the biggest ones. But I would add that I also know that for a lot of organizations, the cost cap will be the biggest one, and it's a progressive cost cap. So before you hit the budget or the end of the budget, Omnigent will prompt you to, I have to be careful with the word prompt because it's a more specific meaning nowadays, but it will tell you to switch to a cheaper model. Yeah. So instead of hard stop, where I'm out of tokens, and that's the new, it's compiling for developers, like I will go out, it's compiling, I'm out of token budget, so I will just grab a coffee for the next 2 hours. It will tell you that maybe you should switch to a cheaper model, and you lose the coffee, but you gain a lot of productivity there.
So just to close this discussion out, where do you see this meta harness in the future, a year from now? And generally, just as a final question, everything that we've been talking about so far, where do you see the next year in Databricks? New announcements?
Yes. So I hope that it's not going to be a meta harness. Or I hope we won't change the name. That's the other one. But
they will. We know.
Yeah, we'll see. I think it's going to be the different interfaces that you use to work in these meta harnesses. So I usually work now with the meta harness. I work in the browser, but you also have a mobile app. Oh, I think they will have a mobile app because I don't think it's out as far as I know. But and then the collaboration feature. Yeah. So if you look at that, it's entirely possible that in the future teams will work on code together, like in a Google Docs. And you never really had that. Like GitHub was more of a central place, and GitHub tried to do things with comments and stuff. But if the meta harness really becomes this developer environment, because people will just generally be there, and it can become, I'm not sure, I think it's still more likely it won't, but it can entirely become the place where we develop the software. So, and I think it naturally aligns with what we see out with the most mature, like agentic use-wise, most mature companies, that they mostly develop code in English now.
Yeah.
or they use English to describe what they want. And then if you look at that, then the future of development interface might be more like a Google Docs rather than a terminal.
Okay. Thank you so much. Thank you so much for being here and taking your time to discuss these topics. And come see us on another episode of the Databricks Release Notes Decoded. Bye-bye.
Bye.